Hello, everyone, and thank you for joining this session. My name is Ankit Rana, and today I'll be talking about scaling embedded systems from prototype to mass production. In my 15 years working as an electrical hardware design engineer in companies like Amazon, Doppler Labs, Jawbone, I've seen firsthand how clever prototypes often stumble when asked to scale. My goal today is to share practical insights that help bridge that gap. Let's start with the reality gap. In a lab, a prototype is about proving a concept. You pick components freely, hand solder boards, and optimize purely for performance. But in production, the rules change. Supply chains dictate availability, costs must be balanced, and quality has to hold up across hundreds of thousands of units. Understanding this shift early saves you from expensive redesigns later. It's not just about whether the prototype works, it's about whether it scales. There are three fundamentals I always stress: component standardization. Reducing unique part numbers by 40 to 60% can simplify your supply chain and speed up assembly. Think of standard resistors, resistor values, or connector types. Second one is the assembly automation. Your PCB layout should make life easier for pick and place machines. Consistent orientations, proper spacing, and accessible test points. And the third is tolerance engineering. Build robustness into your design. Account for manufacturing variations, thermal expansion, and tolerance stackups so that every unit, not just the first, works reliably. These fundamentals are like preventive medicine. A little upfront effort avoids big mistakes later. Another critical approach is modular design. Break down core functions, power, processing, connectivity into distinct modules. Standardize interfaces so that they can be reused across product lines. And design with scalability in mind so that you can use the same architecture for entry level and premium variants of your products. This not only reduces risks, but also buys you flexibility for future updates. At scale, your biggest enemy can be a single unavailable component. Multi-sourcing and early supplier relationship are crucial. Also, keep an eye on life cycle status. Obsolescence notices can derail production plans. And remember, cost optimization isn't just about price tag of a chip, it's about the total cost of ownership, assembly, testing, and even field support. As you prepare for production, testing becomes your safety net. Automated calibration systems ensure every unit leaves the line consistent. End of line testing validates crucial functions without slowing down throughput. Quality control checkpoints combined with statistical process control maintains yield at scale. And finally, field reliability monitoring gives you real world feedback to continuously improve. The key is balancing thorough validation with practicalities of cycle time and production volume. Design validation testing proves margins across environment, electrical and mechanical. Production tests then screen the few critical parameters quickly and repeatably. Design for fixtures and automation early. After launch, monitor the field. Real world telemetry closes the loop, tightening limits and improving reliability without slowing the line. Every embedded system lives in a triangle: performance, reliability, and cost. Pushing too hard on one corner and the other suffers. The real art is balancing all three. That balance depends on your domain, whether it's wearables, automotive, or smart home, but the principle is universal. To sum it all up, start with design for manufacturing early. Build strong supplier relationships. Design for automated assembly and testing, and validate at every milestone. That's how prototypes transform into products that don't just work in the lab, they succeed in the market.